Well, I have a string. Let it be, let's say that it's hello world. I have another string. I want you to really know this. The string in Go is quite complex internal structure. It's not the normal character array. It's more than that. It does many things. Uh, it does many things. Okay. What I mean to say is it does many things, but it's not a character array. Okay, it's not a array of by default. It's not array of characters. It's array of bytes that we have been discussing about it. And we also gone through once that if you want to iterate, like I can say I equal to 0, I less than length of str1, I plus plus, str1 of I, converting it to string, it's going to print the string. Let me put it as print, and let me put it as print line statement. It prints hello world. If I try to do the same thing with the str2, we already knew the problem. There is a problem with str2. It gives ASCII characters because every byte, it's a bytes actually, it's collection of bytes. This is three bytes, this is 3 bytes, and this is 1 byte, this is 1 byte, and the rest of them are 3 bytes. That's the reason you could see space, you could get it, the comma you could get it, the other characters you don't get it. So whenever you are processing strings, it's always good to use. Already we knew that it is always good idea to use a uh, range loop than a normal loop. Okay, range loop is quite intelligent. It can process the string character by character. That also we have seen that for index comma value range of str2 print line print v string of v. It going to work with the character by character, but when you use a normal loop, it takes byte by byte. So we are going to complete with the map slices and all. We are going to the next concept. So just would like to explain one more thing. What if I convert the string to the Rune array? I can, you can do one thing. You can convert the string with a byte array. Then it is going to be bytes. You can convert the string to runes. Some people also pronounce it as rune. Some pronounce it as rune. The difference is, so you can convert, each character can be converted, the character can be converted to rune as well. The character can be converted to byte as well. You see that byte, this is converted to bytes. So if you do that for str1, it works very well, but if you do it with str2, it doesn't work because it's not byte by byte. It's a characters are collection of multiple bytes. Okay, for range comma value range of bytes, or you can use a normal loop as well. For I equal to 0, I less than length of bytes, I plus plus, fmt dot print. You can see bytes of I, you can convert it as a string. You know what it does? Similarly, you can do the same thing with runes. You can do that. So it can convert the bytes as rune. If you so the character array can be the string can be converted to rune array. So when should you convert the string to byte array, a slice, a collection of bytes? When should you convert it to uh, collection of runes? It depends on what that string contains as well. But if you don't worry about all these things, you don't want to really do that. You can directly use the range on a string. It always work with uh, character by character. Whatever the character it has got, it works character by character. There is no problem at all. Okay. So that's something that you need to know. Fine. I hope you understand the concept. How you can convert a string to bytes and then how you can convert a string to rune, etc. Okay. I have a we already discussed something about okay, let me convert this 35 as 35 MISC miscellaneous. Okay, I assume that this is a miscellaneous examples. Okay, converting to rune array and etc. That means this is converting to rune array. Rune slice, that is what we have done. Okay, let me converting Chinese string to rune slice. So you can iterate through the slice. Okay, fine. The next concept is I'm just explaining some miscellaneous things. So you see that actually, if you really look at it, we have done something called SHA-1. SHA-SUM, SHA secured hashing algorithm. Let's say I give a string echo. Let me give it as hello world SHA-1. I can get the SHA over here. The secured hashing algorithm of this string called hello world. Okay. This is SHA-1 is a tool actually that is available on my machine. Mostly in Windows machine also similar tools might be available. Okay. Unix based machines, SHA-1. This is SHA. There are a lot of SHA algorithms are there. SHA-1, SHA-256, SHA-384, etc. There are a lot of SHA-512. There are a lot of algorithms are there. These algorithms are also available, uh, you know, in the machine in the Golang package, which is called crypto package. There is a package called crypto. So when I go to yeah, here crypto package is there. Crypto. There is a package. Sorry, there is a package called crypto. Crypto has got something called SHA-1. Okay, SHA-1.new. I got hash dot, you know, uh, sum. Okay, dot sum. I need to pass the byte. So I say byte array of str1. I get SHA-1 hash. So you get a byte array of SHA-1. Let me convert it as string. So you got some hash code of this particular byte array. Okay. So in fact, you can also convert. You can also get the uh, SHA of. You can also get the SHA of secured hashing algorithm of uh, byte array. You can take the new SHA-1. You can get the. I'm sorry, it's not sum. I'm very sorry. You take the hash. You take the hash, and then you have to write the hash. That means I would like to write it as byte array we need. So I convert byte array of uh, st str1. Uh, you get the, and then of course you may get the error as well. Okay. So if error not equal to nil, that means there got to be error. Otherwise, if error not equal to nil, you get the uh, otherwise. So you get the SHA. Okay, if there is, it's not equal to nil, you get the SHA hash dot write of str. Okay, and then you have to convert it to the hexadecimal format. So you get hash dot write. What it does, okay, number of characters. I'm sorry, this is number of characters. I don't want number of characters. Assume that I'm not going to get any error over here. So I write it to SHA. Okay, I write it to SHA hash. I'm sorry, I write it to hash. So I write this string to hash. Then what happened is there is a hex package because we have to convert it to hexadecimal. I can encode this to string. What should I encode to string is hash dot sum of whatever the sum that I would get it. I'm just encoding it to the string. So it is encoded. Okay. SHA-1 hash, you get it. You can print it. SHA-1 hash. This is the encoded string. Okay. That means which is equal to echo hello world. SHA-1, this is equal to this. Both of them are, but two different, this algorithm is different. It's using internally some different algorithm, but however, so what you are doing is, this is a different thing. How do you write hash code? We can write hash code of hash code, which is called SHA-1 of str1. Okay, so what we are doing here, we take a new hash code. It's going to create a new algorithm, a new object of that. We write that string to hash. Okay, we write the string to hash. That means that is returned to hash. After that, so SHA.sum is a function. Sum appends the current hash to B, okay, internally and returns the resulting slice. Sum is going to append the existing hash. That means this particular write whatever is written to B internally, and then that we are converting to the hexadecimal. This is, of course, we have to follow these three steps in order to get the SHA. Similarly, we want to get another, instead of SHA, we have to SHA-256 algorithm also, you can say. You can take new SHA-256 hash 256. Similarly, hash 256 dot write, you got to write it, the string byte of str1, and then it's written. Then ultimately we need the hex dot encode to string. We are encoding this, whatever is generated to string. Ultimately we have to pass the byte. So directly we can pass the byte, but here we have to pass the bytes from the hash 256 dot sum. We are not going to add any other data, just put it nil because already we got the data. So you here SHA-256 hash, you got to get it, and then we print this. This is the 256 hash. You know, programmatically you may have to generate the hashes. Okay, then in that case you can also use the SHA. SHA means secured hashing algorithm, which also we call it as a SHA. Just explaining the miscellaneous things, certain things. Uh, uh, just want to explain the some miscellaneous things. Okay, and let me go to the another example. CP stub 36 miscellaneous. Sorry. Okay. There is something called big integer in Golang. Okay. Big integer are generally, if you want to really work with very, very big integers, we have something called a big integer in Golang. But big integers means the integers which are really very big. Okay, because uh, see, some programming languages, there is a built-in type called big int. Big int means the integer which is beyond 64 bit. In Rust and all, there is int 128 is also there, but in Go, the maximum size is int 64. We cannot go beyond int 64. But there is no big integer as such. But if you want to use big integers, there is a package in the math sub package, import math big int. There is something called math big int. Sorry, math big. It's a package. Math big is the package. You know that this is a blank identifier. So what generally big int does? You can perform big operations, big integer operations with the big int. Okay, what operations generally we perform mathematical operations. I'm talking about mathematical operations. So let's say that I want to create two variables where okay a comma b uh, int 64 for example equal to some number some number. See, this is the maximum range. See, it's this is the maximum range I can have A and B. Some range. Maximum range means there is a maximum. Uh, how do you get the maximum number? There is you want to get what is the maximum number of a variable. We have in the math package. Let me print this. In the math package, you can have max int 64. This is going to give you what is the maximum integer of int 64. Okay, in the math package. This is the maximum number of an integer. Okay, let's say I take two integers, okay, which is of two maximum integers. I want to perform an operation like a plus b. Definitely, I don't get the expected result. The reason is a plus b are already beyond actually the maximum number because a is a maximum of the this is let me do some this way. A equal to maximum of this, b equal to maximum of this. A and b are two numbers which have got the maximum value of int 64. If I put u into 64, I want to perform an operation because it's a u int 64. Let's say plus 1. Uh, okay, I'm sorry. U int for 64 is different. Okay, again, you don't get the proper result. You see this, you got 98. So, however, let's talk with the u into 64. Very rarely you come across because you don't get the uh, you don't get to work with the numbers which are beyond actually maximum, uh, but still you want to work with these maximum values. Okay, there is a minimum value and then there is also a minimum maximum value. You want to know what could be the minimum value. You can also say fmt.println because it's a uh, math dot minimum int 64. You get the negative value. What is going to be the minimum value of a integer? This is the minimum value. This is the maximum value. Okay, of uint. However, I'm trying to adding two maximum values of int 64. This is going to give you the wrong result. The reason is pretty simple. Okay, the reason is pretty simple. Okay, you know the reason. It's going beyond the actually the size of that integer. So in these such cases, okay, you can use something called a big integer in Go language, something called big int. Let's say that a and b, let me put it as a1 and then b1, a1 and b1, I got to give it as c1, and we know it gives a wrong result that we already know. Now what I do is a2 equal to big dot new int. So here I'm going to give you a very big integer, even give you 9. I have added this, a new integer. Okay, a2. So it gives you a2 is a pointer of big int. Similarly, I give something called b2 as a big integer of this. That means I cannot go and give more than this number. That is something, but I can give up to this number. But I'm trying to perform an operation on a big integer. Okay, I can. What I can do is I want to create an operation. Let's say, however, it's a pointer new big dot integer dot add of a2 comma b2. I want to perform a2 comma b2. Let me put it as c2 fmt dot println c2. This is going to be, you get the result because it's a big integer. Otherwise you can also create something called a new big integer c2 equal to big dot new integer, maybe 0 you can give, and then you can give c2 dot as well. Okay, or you can give this way as well. However, because it's a pointer ultimately, because star big int, so you can perform an addition of two big integers. You can perform which goes beyond int 64. What does it mean is it goes beyond int 64, which is normally it's very difficult to perform this kind of operation uh, on big integers, right? You can also perform the multiplication operation as well. Let's say this is pretty small. Let's say I say product of numbers, okay, p2, or multiplication of numbers m2 equal to new of big dot int of, okay, dot multiply of a2 comma b2, you know um, which is going to, it goes actually beyond that limit. See, that's such a big numbers, you cannot directly work with normal integers. You have to use big integers. Very few people know about this actually. If you're performing very big operations and all, Golang will support, but not directly. You have to use an additional package called big integer. What is the limitation of big integer? Big integer, you can create a big integer, but the parameters should be this kind of big integers. Okay, you cannot go and then give, you cannot give let's say I want to perform an operation on a big integer. You have to perform an operation on a big integer by two big integers. You see that two big integers. Okay. Can I do with the C2? You can do with C2. C2 is beyond actually. C2 is a big integer. The multiplication operation on two big integers. You see that the multiplication operation is on two big integers. Let's say you want to perform very big operation on big integers, then you create two big integers and then perform the multiplication operation. But if you use a new integer, you should always use int 64 is the range to create a big integer. You want to perform operation on big integer, you can split it into two integers with the size of int 64 and then pass it as a new two big integers, and then of course you can perform the operation. So big integer is the concept that you have to use in order to perform these operations. Okay. uh, okay, that's what about the big integer. And then there is a package called atomic. Okay. uh, you should understand the concept of atomic operations. Okay. Atomic operations generally, for example, if you look for any kind of an operation, okay, in Go language, let's say that I give it something called, okay, A1 C AC2. Okay, let me give it as ABC equal to 10, 20, 30. I give three integers. ABC are 10, 20, 30. Okay. I want to perform an atomic operation on ABC. Okay. Generally, if I want to perform an atomic operation on ABC, we can discuss more about atomic operations later on as well. We will discuss about the atomic operations on uh, uh, Go routines and Go channels, but just would like to explain what atomic operations are generally. Let's say that I give D equal to A plus B, assume that divided by 100 divided by 2 plus A into B plus A by B plus C plus C into 10. If you really look at this operation, what would be the result of D? What is the result of D? How does the result is evaluated of D? How this particular expression is, I don't know, it's a meaningless expression. If you ask me why do you write this expression, I don't have any answer. I'm just writing some expression. This expression is going to give you some result. Okay. If you really break down this expression from the uh, assembly language perspective, the whole expression is divided into multiple sub expressions. The whole expression is divided into multiple sub expressions. That's what it happens. Okay, because if you look at any assembly language code, there is also add expression, there is move, there could be subtract, there could be multiply, there could be divide. These are the expressions of your assembly language. Mostly, any assembly language. These are but these are the operations you can perform. So the whole expression is split into multiple operations, and then the values are stored inside the registries. So this is not one with respect to your computer language, Go language or C language or in Python or anything. This could be one expression. But with respect to assembly language, this is not one expression. These are multiple expressions. How the expressions are followed or given based on the precedence of the operators. You know that. So which operator has got the highest precedence? Generally, the parenthesis has got the highest precedence. Some operators has got equal precedence. For example, divided by and then a multiplication operator or has got the equal precedence. Then, but the precedence is always from left to right. The left hand side is taken the highest priority. Okay. So in this particular expression, if you really look at it, a by b, a plus b by 2 is first evaluated. What is the value of a? It is 20, 10 plus 20 by 2. You know how it goes. 10 plus 20 by 2, which is called 13, 30 by 2, which is called 15, is first done. Then the multiplication has got the highest precedence. A into B, 10 into 20, it has got 200. And then A by B, that means 10 by 20. How much it is? What is 10 by 20? Plus C, which has got 30, plus C into 10, 30 into 10, 300. This is how the entire expression, and then the multiplication, the addition happens because all of them are equal operators. So this is not, let's say that if I put uh, a plus b over here, this expression is evaluated before this expression. This expression is evaluated before this expression. That means a by b, wherever it is 10, then what happens? C plus a plus b, 30 plus 10 plus 20. Okay, but this is evaluated. Next iteration, it becomes 15 plus 200 plus 0 plus this is evaluated 30 plus 50. Okay, 40, 50 plus 300. Sorry, 300. That means 15 plus all of them now have the equal priority. All of them has got the equal precedence. 15 plus 200, 215 plus 50, 265, 265 plus 300, which is called 565. That's what the value that you get it as a D. Okay, 575. Maybe something went wrong. 575 is the uh, value that is evaluated. 575 is the value that gets evaluated. Why it is evaluated? A plus b by 2. A plus b by 2. If you really put it this way, it just got 15. Okay, plus a into b, a into b, 10 into 200 plus a into b, 215 plus a by b, again it is 215 plus c plus a plus b, c plus a plus b, that means 30 plus 10 plus 20, which is called 30 plus 10, 40 plus 20, 60. I did some mistake. I did 50 here. It got to be 60. That's where the problem is. Plus c into 10, and you know how that is how the expressions are evaluated. But the concept is this is not the atomic operation. Atomic operation because all these operation expression is split into multiple operations. Atomic operation means the whole operation happens at once in a single instance. I'm not saying single instruction, but single instance. From the processor perspective, it means a lot actually. It means a lot. Why do I say what do I say it means a lot? Because atomic operations, because whenever the process is processing something, it goes back. Sorry, there is a context which happens between the processor, the context which happens between the processing. Then it may halt that particular operation, go to the other thread, execute the operation, and comes back. It may, we don't know, it may, while performing this operation, it may switch back and then come back. It, even though it happens in a fraction of seconds, generally fraction of milliseconds, okay, the context which happens, we don't see it, but actually it may or may not happen in a single instance. So this is a problem particularly with the multi-threaded applications. It's a very big problem with the multi-threaded applications. Okay. So there is a package called Atomic. If you perform the atomic operation, okay, if you perform an atomic operation in Go language, there is something called atomic. If you perform the atomic operation in Go language, the entire operation happens in a single instance. That's what the atomic operation. Okay, that's what the atomic operation happens. So there is a package called atomic package. Okay, so atomic operations are generally simple performing operations, storing, adding, or swapping values. Generally, they don't do very complex arithmetic operations as atomic operations, but yet, you can perform them as an atomic operations as well. Okay, you can perform them as an atomic operations as well. But atomic, that is the uh, that's what the atomic operation is. Okay, that's what the atomic operation is. Let's say that I want to perform an atomic operation of generally we don't do atomic operations for these kind of expressions, but generally telling how this expression is evaluated. Okay, which operation has to be executed when there is a context switch and all taken care by your microprocessor. Okay, there is a program counter that takes care of it. We will discuss about it in threading, multi-thread, I mean Go routines and etc. I will explain that. Okay. For example, I have the same. What I can do is, let's say value A equal to atomic dot load int 64 of address of A, because it may take it as int 32 as well on other. Val B equal to atomic of load int 64 of address of B. For example, I have two operations, two variables. I load it as atomic operations. Okay. So I want to perform some result equal to, for example, I want to perform something like this: a plus b divided by into uh, maybe a plus b into a plus b, for example. This is what the result I would like to perform. Let me a plus b minus a minus b. I can say val a plus val b into val a minus val b. I get the result. If you want to store the result into a another variable, maybe let me put it as local result. This got to be the local result, and I want to store the result in a variable. Let me see, as result is int64, where result is int64. I want to put a result atomic dot store result of, so the result comma local result. We want to get the result into the result variable fmt.println result 190. Even though it looks pretty simple, why do you want to really perform this operation? A into b, a plus b uh, into a minus b. Okay, uh, uh, okay, a plus b into a minus b. Even though it looks, because see, the result is different now. Earlier the result is different. Earlier what happened is, if you really look at it, what happens is it does a b into a. That means how much it is? uh, it was 20 into 10. 20 into 10 is how much? 20 into 10, 200. 10, 200 plus 200 plus 20, 220 or something. 200 minus 10, 190 something one. Somehow it gives the result, but now it is different. The moment you put this, okay, the concept is different because the priority precedence goes different. Okay, 300 into something minus 300, however it gave a plus b into a minus b, whichever has got the highest precedence, it get the result. However, that is how the atomic. So here the concept is, what is the difference between this and then? This is an atomic operation. You are performing an atomic operation. So atomic operations are executed by single instance. Okay, exactly in this particular scenario, 100% it may not perform in a single instance, but generally, if you put it like this, atomic dot add 64, okay, of val a comma some delta, I give some number, okay, address of a, add int 64, address of a. This is 100% atomic operation. You are going to get some result. If I perform plus, okay, atomic of something, some number, let's say I give as b, delta, so I give b, you get a result plus atomic dot atomic dot. Okay. uh, Add in 64 of A. I give as A comma B, for example. Something like that. When you use this is an atomic operation. However, the concept of atomic operations are operations that have to be performed in one instance. You can see a lot of things are there in atomic variables. Perform operations that are supposed to be performed in single instance. Uh, One thing is particularly when you are using the concurrency, when you come to the concurrency, you have to use the atomic operation. Okay. So atomic operations ensure the thread safety mechanism, and then you can also perform the concurrent operations, complex arithmetic operations, complex computations in a concurrent multiple threads and etc. Okay. We'll see about it in a later, just explaining some kind of a miscellaneous things. So just brought all the things. We will see them. We will see these things even a later part of the course as well. Just explaining you certain things. Okay. So what all we discussed? We discussed about how do you, sorry, we discussed about uh, how do you convert a string to Rune array, a Rune slice, and byte slice. We show the difference. I showed you the difference. You can convert it to Rune slice or byte slice, but the size of this is bigger than this, even though you are working with both, because each character is each byte is converted to Rune. Actually, you have to check it. Uh, okay. Let me check the length of. Let me check it once again. Print line, length of bytes, length of bytes, length of runes, length of characters. So length of characters is 5. Okay, it could fit it as 5 characters. That means 1, 2, 3, 4, 5, 5 characters, but 5 into 4 bytes. Remember that it's 5 into 4 bytes, because each character is a size is different, length is different, right? If you look at the size of bytes, there is something called unsafe dot size of bytes. Similarly, we have size of characters. Okay. Oh, size means I'm very, very sorry. Again, the size talks about the size of the slice header. I'm very sorry. The slice of the slice header. But basically, yeah, size of the slice header is always 24 bytes. Sorry for that. But actually, if you look for the length of the bytes, what is the length of the bytes? Each byte, which is 15 into 1, which is called 15 bytes. Here, 5 into 4, 5 into 4, which goes as 24 bytes. Even if you go for characters, let's say character 2 of, I can give rune of str1. If you really look at it, str1, all the characters are is none of the character is actually none of the character is a special character. Still, you got it as 11. Uh, uh, Length of character 2 is given as 11. That means how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 characters are there. Whenever I create it as a rune, okay, but each character can be treated as a rune. The size is 24. Okay, 1 minute. Each character is converted as a rune, but the character can be converted as a rune, but the length is still it is showing as 11 bytes, even whether bytes are rune. Bytes, bytes or normal bytes or rune actually, whether yeah, rune character 2. It is showing as 11 bytes. The total number of characters are 11, but when you try to pick each and every character, each character is exactly taken as, again, if you are converted as a rune, for example, I want to pick the rune. Let me go here. I want to go for rune for I equal to 0, I less than, sorry, I less than length of characters 2, I plus plus. So fmt dot print of uh, character 2 of I. Okay, and then I print line before hash code 1. Let me convert it as string. So hello world is properly picked. So actually what happened there is each character is 1 byte. Each character is actually 1 byte, but we are taking each character as 4 bytes when you convert it as a rune. The length of the rune is 11, but actually each character is 1 byte, but we are taking as each character as 4 bytes basically when you convert it as rune, because each rune is 4 bytes. But what happened? There is some padding happens. Padding means one four bytes are the block of four bytes are taken, but there is a padding of 3 bytes for each and every character it takes. Okay. However, that's not a problem. That is not a problem with respect to room. Let's say that I want to print fmt dot print of let me size of each character. Okay, size of each character. What I do is unsafe dot size of chars of I. You see that each character has taken four bytes. Each character is taken as four bytes. But when you look at the length, still the length is tells that it is 11 bytes because it is taking the length of a string. The length is trying to, you know, club the number of characters that are available on Rune. Uh, okay, char2. Whenever you try to put the length of a char2, it is giving as 11. Okay, uh, 11 means what actually? 11 into 4. Remember that 11 means what? It's not 11 characters. 11 into 4, 44 bytes. Okay, the size is 44 bytes. This is the size of the string slice header. This is 11 means what? It's not 11 characters, 11 bytes. Remember that. String is different. String gives you the bytes because the internally string stores in the form of bytes. But whenever you are converted to Rune, each character is 4 bytes. So 11 means what? 11 into 4, 44 bytes. You understand the same string we are talking about str1, uh, you know, actually it is only 11 bytes. When you treat it as everything as a rune, it is 44 bytes, almost 33 bytes extra. That's the reason go carefully understand what each character is, what is the size of each character, whether it can be fit into 1 byte, 2 byte, 3 byte, etc. Based on that, okay, it gives the uh, it 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 efficiently fit that particular character into the stuff. That's very important thing with respect to Golang. That's the reason when someone asks what is a string, is a string uh, character of bytes, character of I mean string is a collection of bytes or a collection of rune. String is always collection of bytes. String is not collection of rune. But here what we did, we converted to rune. This is not the original form of string. We converted it to rune. Okay. Here we converted it to bytes. Then the str2, which has got a Chinese characters, each character is split into 3 bytes. Basically, that is how the string is. This is 3 bytes, this is 3 bytes. Comma is 1 byte, space is 1 byte. This is 3 byte and 3 byte. 3 plus 3, 6, 7, 8, 8 plus 6, 14 bytes. But it doesn't, here it is 11 bytes. So Go doesn't go and store each character is 4 bytes, like unlike many programming languages. So I always say the string in Go are very complex from the internal implementation and very intelligent characters. Okay. So when you want to access string, some folks do like this. Convert the string into rune or convert the string into byte. So when you have normal characters, you can convert it to byte. You don't need to convert to byte or rune, just use a range loop. Range loop is capable of accessing all the strings. Just use the range loop. Range loop is very intelligent loop. You don't need to do anything. Fine. Coming to the hashing and all, hashing algorithms are already there in crypto package. You can perform hashing on the crypto package. How do you perform hash operations? Hash SHA-1, SHA-256, SHA-512, etc. There are algorithms available. You can use those algorithms. Okay, for hashing. You saw that. And coming back here, you want to work with very big numbers. You want to perform an operation of adding two maximum size integer 64s, then definitely you can't perform the operation. So there is a concept of big integers come into the picture. Okay, you can use big integers are from the math package called big. You can add two big integers and get the result. You can multiply two big integers and get the result, etc. You can perform basic arithmetic operations. Okay, and there is atomic operation. I just explained what actually expression is, what an expression is, how the expressions are split. Okay, what is an expression? Expression returns a result. Okay, how an expression is split into multiple commands from assembly language perspective. Okay, it perform the operation into multiple add, subtract, all the operations. So what atomic operations are? Generally atomic operations are atomic in nature. The whole operation happens in one instance. Why atomic operations are used? You can use normal expressions inside of atomic operations. So particularly atomic operations will safeguard from the race conditions due to the concurrency during multiple threads want to access the uh, operation, then it ensures that the whole operation happens at one instance, and it guards from the other thread trying to access that particular variable during the operation. It safeguard that particular operation. Generally, you can use mutexes as well. Just showed you that how to load variables into atomic and then perform a simple atomic operation. Just nothing to do anything. Just showed you that there is a package called sync.atomic, and then you can perform all these atomic operations using sync package. These are all miscellaneous things that we have discussed. So tomorrow's session we are going to start with the user-defined types. These things I just explained so that you understand certain things are there in Go which are uh, you can perform all these operations by using these packages. That's what I about the session.